We have our Proof Mania panel up right now. Rollups are really hot, as we've seen, like with Avail, and they've been kind of trying to solve a very core problem in terms of fragmentation. But at RISC Zero, we work very closely with a lot of different rollup partners for enabling ZK proofs. And today we have Yuan from Blockchain Capital moderating with the founders of Taiko, Citrea, Matter Labs, and Scroll. So it's going to be a very, very exciting panel. Thank you all for being here.
This would be better.
We have three.
Thank you everyone for being here. Today we're going to talk about proofs, all different kinds of proofs. To start us off, I think it'd be great if each of you could briefly introduce yourselves and the project or company you work for. And then from there we can kind of get into things. Brecht, maybe you start.
Hi, I'm Brecht. I work at Taiko. At Taiko we're trying to build like a based ZK VM rollup. Launched around like a month ago. So currently we are based, but not really a ZK VM yet. And I guess relevant to the discussion, we currently have like SGX proofs live on mainnet. But yeah, working towards more TE proofs and actually the ZK proving part.
Hey everyone, I'm Orkun. I'm co-founder of Citrea, and Citrea is Bitcoin's first ZK rollup that we have been working on for around a year, and now made our work public, including the open source code base and other parts of the VM. We are building a Type 2 ZK VM, or trying to build a Type 2 ZK VM for now, and the devnet is just went live, but we are still not on testnet or mainnet.
Hi, my name is Daniel Lumi. I'm the senior product manager of ZK Stack for ZKsync at Matter Labs. It's a mouthful. We're building the Elastic chain, which is an elastically scalable blockchain using sovereign instances of ZK chains on a shared contract. And the goal is to make blockchain scale to actually billions of people rather than hoping that some 2030 TPS is enough.
Hi, my name is Ye. I'm co-founder of Scroll. So Scroll is working on so far Scroll is the most EVM compatible ZK EVM based rollup on the mainnet, and we have been running for a year. And and recently our not just tech, we are building one of the fastest ZK EVM, and also working over our next generation, which might bring even cheaper prover and faster finality. And also we are seeing huge ecosystem growth recently, so hopefully we can soon become liquidity also #1 of among other ZK rollups. And
So I think to start first, I know some of you have mentioned it, and it's probably obvious from the names of what you guys are working on, but just quickly, what proofs does a rollup you're at currently use?
Yeah, currently on mainnet we have the SGX proof, like I said before. But yeah, obviously that's not a great situation to be in. So next month we hopefully have a ZK proof live. So either with RISC Zero or SP1's ZKsync's SP1 ZK VM. So yeah, we try to move towards the ZK VM. We kind of prove things because until 6-9 months ago, we were working together with Scroll as well on the the custom way to write custom circuits to implement the whole EVM stuff. Also all the extra functionality that the EVM needs to be Ethereum equivalent, which is a lot of work, and also security-wise, work-wise, it's a serious undertaking. And by switching to ZK VM approach, we can actually reuse all the node implementations that are currently available. So 2 weeks ago, or last week, we actually moved completely to a RETH-based implementation to proof. So we basically just proof RETH as this, so we don't have to maintain lots of things. So if RETH upgrades, Ethereum upgrades, then we just have to prove whatever nodes are already using. So that's the benefit there. And also yeah, SGX proof or like any of these DE proofs, obviously you can also just run normal Rust code or like get code, Go code for like get. So we can just reuse the same code base, and kind of like the backend is kind of like abstract or doesn't matter that much.
And we have a custom client similar and running REVM inside of it, of Paradigm, and we are also using RISC Zero to generate our Stark proofs. But essentially our proofs wrapped into FF long instead of keep or Stark or gross 16 because of Bitcoin's limitation. And then we also have a fraud proofs, which doesn't live yet. So the thing is, it's optimistically verified ZK rollup because of Bitcoin's complexities, but the fraud proof part for it is not live yet.
So we use Bujum, which is an implementation of the originally Redshift paper. We also use Reth, but we have a custom implementation of EVM, and the reason why is because of scalability. It just currently generalized ZK VMs don't quite get us further enough for that to be able to enable these largely scalable applications. We have also SGX coming as a two-factor redundancy on testnet, hopefully this or next week. Oh, someone's gonna kill me for saying that. Yeah, we are also working on our own ZK VM, but we want to, it's critically important, and we're working on a Rust-based EDSL called CLAP to enable a truly multi-prover system for different types of ZK proofs, as well as different types of SGX proof to be able to run in parallel, to really just make it ultra hardened to the point that no one can steal anything. And then you can build completely custom programs as rollups into the Elastic chain. NVMs, including Solana and others.
So we have a production ready type 2 ZK VM running on mainnet. That's one thing which you already know, and we have built very fast GPU prover to make the prover really fast. And internally we are also working on next generation ZK VM to make that even faster. And right now we already also get the Rust-based sequencer working, REVM working in a ZK VM context, but the backend work needs a lot of optimization on the prover side, and we are working on some GKR-based proving system, which I think there are some benchmarks showing that it's significantly faster, and but needs a lot of new work to do because it's it's maybe too frontier to kind of there are a lot of implementation work needed. So that's another thing we are working on. And previously, I think months ago, we also have I think it's probably the first release for also a real multi-prover with SGX as in addition to the original ZK prover. So it's in collaboration with Automata team, and but it's not on mainnet yet. They build an AVS service for that, and anyone want to use Scroll Tech Stack can also launch with that. But so far, because we do notice right now people's main demand are on the kind of user experience, cheaper fee, and then that's why we are kind of trying to think about how we prioritize over when we bring more multi-prover to the mainnet, and what should we prioritize for. But we already get that working, so it's anyone want to kind of run that, you can feel free to run that. So also three, basically ZK EVM, ZK VM, and SGX are there.
So it sounds like, 3 of the 4 of you obviously all have ZKPs live in production, and are working towards getting SGX live soon too, and are all broadly moving towards this multi-prover setup. Obviously you guys are a little further behind. But yeah, I guess maybe starting high level, why does a multi-prover setup make sense, right? I think if you think about from first principles, you are losing some things, right? In that, okay, maybe now to truly finalize, you need to wait for multiple types of proofs to generate. Some might be slower than others. But yeah, as you guys were thinking through this decision matrix, why do a multi-prover? Why does it make sense?
So yeah,
you
I
have to if you're responsible. You have to if you're responsible.
Yeah. So yeah, the only reason to do this is for security purposes. So yeah, making one thing secure is hard. Making 3 things secure is also hard. But I guess the idea here is that they have bugs in different places, and they also work significantly different. So yeah, a TE proof works very differently than a ZK proof. So you kind of hope that at least like one of them holds up for like a specific bug and the other one. And like the cost wise, yeah, so the reason you still want to kind of like have multiple at the same time is kind of like for finality reasons. So if you use them in like some kind of like fraud-proof system, it also works, kind of like from like a security point of view mostly. But you do lose the aspect of like, yeah, why are you even using validity proofs to begin with? It's kind of like the fast finality that you get, like on-chain finality that you get from yeah, validity proofs. So yeah, to have like the security plus fast finality, yeah, the extra cost of like a multi-proof makes sense, and especially if you can combine it with like a proof aggregation, then actually, yeah, the verification cost, at least you can also like aggregate on chain, so it's kind of like a pretty small cost. But obviously, you still have to prove all the blocks off chain. So if the proving cost is actually cheap, then kind of like this whole system can actually be pretty cheap as well.
Yeah, as a project, we are not still yet there to become using multi-proofs. But I think the important thing is like the upgradability is fine if there's an exit window. But if you want like remove all the multi-sigs, we need some kind of provable bug detection, which can only be possible using multiple provers. Because if there's any bug in your proof system, then all the assets can be stolen. In order to prevent that, we need some kind of game and detectable bugs. I think that's why multi-prover is very, very important. And all the developing new ZK VMs, they're usually compatible with risc-v, so that's also one advantage, that you don't need to build everything from scratch for every single update. You can simply reuse the existing code. I think that's also one of the steps that accelerates this multi-prover stuff recently.
Yeah, it's really required to, like, people have this goal of becoming stage 2, and everyone wants to be stage 2, but the most important thing to think about is, like, in order for rollup to inherit the security of Ethereum, you need to not have multi-sigs. You need to only be able to do upgrades with delay. Like, today, if there's an implementation, like, ZK is hard, guys. Like, it sounds like we're all converging on the same solution. To some degree, that's true, but the devil's in the fucking details. Like, it's not just the ZK proof, it's the whole platform you build around it. Like, you can't just take a ZK VM and stick it on Optimism and hope that works. Like this is not how rollups work. They're complex code, and you can have bugs in many of these parts, and upgrades are dangerous. Like, one of the biggest things we can do to minimize these bugs is to have like multiple different proof systems. Like in SGX for us, for example, like it can only temporarily freeze the state. Like, we're not still taking any assumptions on Intel itself. Like, it's just a second redundancy if you implemented the verifier wrong, or you have a different outcome running through your prover, that you can just freeze it, make sure no one loses any money in this. And then if you need to upgrade it in a delayed fashion, then you can give time for people to exit.
Yeah, I share a very similar view because I think it's very important. Like, even if you are not using like every block, you use both SGX and ZK proof for making that cheaper or for better liveness. You still need to use that for example, like when you do upgrade, like when you have actually having some conflict, you need to use SGX or some proof to kind of like solve this conflict, because there will be some kind of like cases where, if you really want to remove multi-sig, but you still want to maintain some certain like upgradability and all those stuff, you need this as like, it's not just manually we decided or like, the DAO decided, but it's actually you have some proof, and then to actually, for example, if someone really sends some initial transaction, you can even at that time use an SGX to add another additional guarantee only for this purpose. And for us, like, as I mentioned, like, there are many reasons, like for cost and for liveness, and because I think people only see the security like benefits, and another thing actually might be a downside for multi-prover is liveness, because if you really strictly follow, you need to generate proof for both SGX and like a ZK prover side. If there is anything wrong with your SGX software, like it's, then it might influence your chance liveness. And when you do decentralized prover, you need to consider like that, do you require every mining pool also buying SGX hardware or something, or you only want have a certain committee for like doing this type of thing. So there are actually a lot of things, considerations of how you implement multi-prover and how you bring this into production ready system. So we are super cautious because security has already been our priority, but we want to kind of like gradually add, like as we are more confident, like how this play in decentralized prover setup, and and how this play in the security console setup, upgrade setup, then like we can be more comfortable like moving forward with that.
Maybe I can just add on that of like, you need this to be able to decentralize provers. Like right now it's centralized actors running provers, so like the security council can stop. The problem is now you have an adversarial setup with many different provers that any one of them finds an exploit, they could theoretically steal all the funds. And this like we're also building the elastic chain, so it's many different ZK chains all working together without having to trust each other at all, right? But it increases the surface of adversarial actors. So there's like responsible decisions. Like liveness to me is an acceptable thing. Worst case scenario, you can't use a blockchain for a little bit. Of course, we never want a liveness failure, right? But it at least it doesn't lead to all your money getting stolen, right? Or your tokens getting stolen. Sorry, Rachel from legal. Or your tokens getting stolen. And so you really need this diversity in adversarial environments to be able to make sure that you can decentralize and have many different actors working together without being able to compromise each other.
I want to dive into some of these design considerations you guys are each thinking through in a bit. But before we go there, right? How much as you think through, design this, how much redundancy do you think it's like sufficient? Because obviously with you guys, you have multiple ZK proof systems you guys are planning to implement, as well as SGX. Daniel, it sounds like with you guys, it's just one ZK proof system for now and SGX.
Also more in the future, but yeah. Like
yeah,
we want risc-v also.
So then, when do you think it's enough?
Well, I guess kind of like the previous discussions, like why would you not have like all of them? I guess like one of this is liveness issue because and the other thing is like cost. So otherwise, it's always like beneficial to have like more because you have to either generate the proof or obviously there's like a bug in a proof which stops the chain from finalizing if you actually require that proof to be valid for a specific block. So that's the other risk next to like not generating the proof. It's like the proof generation might not be possible for like a specific block for a specific proof type. So which is kind of like from live is perspective bad, but from a security perspective actually what you want, because if something is wrong, you prefer the chain to stop than to go on with a bug in it, right? Because then you have like the loss of like funds. So yeah, from like a practical point of view, it's kind of like mostly focused on like the cost factor, right? So TE proofs, validating TE proofs can be like very cheap on chain if you use like the trick to not always like check all the remote attestation all the time. So it's kind of like 20,000 gas or something to kind of like validate the proof for a TE proof. Which is like very cheap, especially
Super
if you
cheap.
can aggregate them. So why not have all the TE proofs that you have available is basically my answer to this. Just do as many as you have support. With ZK proofs, it's like more complicated because ZK proving costs money, off-chain, and also like the verification cost, and especially like the off-chain proof generation cost is still like significant now. So you don't want to have like too many for this reason. But as ZK proofs also get cheaper, then multiple ZK proofs also like a good idea in my opinion.
Yeah, not much to add on this thing, but I think proof systems should also evolve and become much more stable than they are today. So that's the one thing. And the other thing is they should be very easy to implement for chain developers. Because if we have to do all the circuit development from scratch for every single proof system that we want to integrate, it will take too much of time. Other than adding other features, we should focus on always updating all the circuits and like implementing new proof systems. So I think arriving into some kind of common interface for all the ZK proofs, especially the ZK VMs, should be important step.
I agree. No, genuinely, like proofs are not a bottleneck for us. Like it will be again L1 gas. Like it's not really the proof. Like we have 1 cent transactions on ZKsync. Like many like L2s do. It's sub-cent for Validium. Like there's a certain point where realistically you can add a couple more subcents, and just for security, right? Like it actually matters for like traditional finance a lot. Those fractions of a penny, people are not thinking quite enough. 1 penny is unacceptable for Visa. But there is some sort of balance even with just pure ZK proofs where it's worth it to have 2 or 3 of them.
Yeah, I think for me, like it's like very likely 3 like will be very likely enough. Like 1 ZK EVM, 1 like more like TE based, 1 ZK VM based, and some can be even training well, and some can only appear on multisig. Because for me, it's like I think till the point of like, because I know like ECM Foundation is also doing research on formification for some ZK VM, ZK EVM research. So I think if once we get some circuit being formally verified, or we get a formally verified some certain library of like mathematical circuit, and then like compose them together, become super secure, and then map to a certain spec, I think that till then, like, you know, you will be more comfortable like of like just having like fewer virtual machines. And also another like even longer, I don't know, longer or like shorter direction is that trying to kind of like ECM, if ECM is really trying to enshrine the EVM into its layer 1 protocol and trying to add protocol support for verification, then like you can safely remove multisig without kind of worrying about anything, because the social consensus will help you to kind of like, you know, if you have bug, you know, like ECM fork, and like, you know, like we're all family, like we upgrade together, and like, you know, it's not one ZK fault. So I think until then, like, you know, we are more comfortable with like removing multisig, but for a long time it will be training well, and yeah.
So another kind of question, I guess mostly more so directed at you, Daniel, because you know, ZKsync is obviously not totally EVM equivalent, whereas I know Taiko and Scroll is. Do you guys feel that this pressure to basically add multi-provers and get to stage 2 makes it harder for you to, you know, it's shifting you guys towards trying to be more EVM equivalent to make things easier, right? Just because it's harder to add these other proof systems if you are not doing what everyone else is doing.
So, well, I mean, it's a Rust-based client, so you can run it on an ZK VM too. Like, again, proving is not the bottleneck. Virtual machines are, like, networking is, database, writing to databases, like local topography. Like, this is why you can't just slap on a ZK prover onto something. Like, we have 180 TPS and Uniswap 2 DEX swaps, which is a standardized like test. Like, it's much more realistic to measure this way than it is with gas per second. That's not a good measurement across different VMs, across different even rollups. That took a shit ton of work, and it wasn't really related as much to the prover side, because in the beginning, like, L2s didn't need to submit proofs that frequently. The thing where this changes also is we're trying to enable this, or we're in the process of enabling this elastic chain ecosystem. So you need really fast proofs, like preferably under a minute, to make essentially all these chains be able to communicate with each other. There are some very, okay, now I'm floating my own boat. We did a good job with the design. It's pretty fucking cool. Like how we can actually get really fast proofs and also get the cost benefits of state diffs amortized over time. ZK Gateway, by the way. Like, it's very different than other solutions out there. But this is like, it's not really the prover side. That's not the part that worries me. The question is, like, Visa does 60,000 TPS on a holiday, right? Like, even if we get to 100,000 TPS, that's nowhere near enough. Like, we're trying to onboard all of traditional finance. Like, I'm not saying just to ZKsync, I mean on blockchain. Like New York Stock Exchange does a stupid amount of transactions. Like every single bank doing transactions through this, Swift, IBAN, like all of this going through blockchain, we need millions of TPS. And as long as we're playing in the ballpark of 100 TPS, 1,000 TPS, 10,000, 100,000, we're not being realistic to where we can scale this technology. So this is why, like of course we research EVM equivalents. In fact, we can enable it today. Like, that's not that hard. It's harder to get it to scale. So there will be some point where people can switch to full EVM equivalents. Until you don't flesh out these systems, you can't get throughput enough to really support these real applications.
I anything you guys
Something I want to challenge. I understand, like, you know, I want to ask you a question, like how you handle the backward compatibility if you are moving to EVM equivalence, because a lot of like contract code, like smart account are built on top of like the current account model of ZKsync specifically, and then like once you support, for example, EVM, and like I know like Create 2 is like behave very differently on ZKsync, how you are going to handle the backward compatibility, because that's one big motivation of like why you want to start with more compatible and then gradually maybe adding some constraints and like, but once you start in a different way, like is there a way to kind of you support multiple different virtual machines, or like how that will work?
Yeah, we can support multiple virtual machines and multiple instances, and you can like the design of L2s will change over time. Like it won't just be like Visa today. When they handle transactions, they don't send every single transaction through one payment gateway. Like the computers aren't that beefy. Like even though we have very beefy computers, they use multiple payment channels. So you could have ZK Visa build on Elastic Chain where they have multiple different rollups, and on a user like interface level, you abstract it away. Someone can send off of this payment channel, someone else receives something from a different payment channel, and you just abstract away which chain anyone's using. Like there are ways to use like the internet is sharded, not sharded, but like you have to scale horizontally. Every type of computing and networking you have to scale horizontally. Like we need to support different VMs, we need to support custom programs and multiple instances. And that's where we're building towards.
I think it's okay for all the teams to like try being EVM equivalent or like try to develop their own EVM. But I think in the future, Ethereum will also move more towards a ZK-friendly EVM implementation on the L1 level itself. Also for stateless clients, follow all the like roadmap of Ethereum. I think through social consensus and like all the research focused on this, we might find even better EVM implementations, ZK-friendly EVM implementations than ZKsync. No offense, just it's all to like try everything right now, and eventually we will have a social consensus on what is best to use in ZK context, and essentially Ethereum will also implement that new EVM, I believe.
If you come up with a better design, build on like Elastic Chain, you can launch, and we're happy to have you. You can have custom VMs, and then that like make competition win. Except in this it's everyone working together. Like it's actually quite in L2s too. Across L2s, like every L2 does certain things better, and we all grow from that together. Like we learn from those things.
So do you think it's worthwhile to have like multiple VMs?
Yeah.
Just for optimization purposes?
Yeah.
For both the node and the ZK proving
Not every
generation
single website in the world uses the same backend. Not every server is running on Linux. Not every server, like yes.
They are not, but they could, I guess is the question.
Again, if you implement, like we have something called ZK IP that we presented at roll call, right? Like you can allow trustlessly different virtual machines, and then similar to any computing environment, like nothing's ever perfect, right? So like you could still have Solidity running somewhere else. I'm not saying it's not messy, but you can actually build quite good SDKs and APIs to abstract this away as much as possible. Like I'm not gonna like, I think EVM is gonna stay, and I think Solidity is gonna stay. Like regardless of whether Solidity is the best language, it's gonna become default, right? And we are building on Ethereum, but different business cases need different implementations. Like a military application doing like just ZK proofs alone is not gonna use a risc-v like prover. It's not fast enough. Like it depends. It depends on what you're building, right?
Most applications do run like x86 or like ARM, and it's like people don't
There's
really
very
care too much.
specialized
Like,
chips in the military as well.
yeah.
I'm not saying that we're
Yeah,
supporting
sure,
the
sure,
military,
sure.
by the way. I'm just saying
pretty-
like
that's
different
pretty
things
far,
built
yeah,
differently. You're right. Most build on standardized architecture.
I'm just saying from like a security point of view, it's also gets like trickier because it has extra complexity, right? So yeah, you can have like a custom VM, but okay, yeah, what's the security? You kind of like want things to interrupt, but you don't know kind of like what the security is, kind of like with the chain you're interacting with. So it's kind of like gets very tricky. Okay.
I think
yeah,
as
but-
long as
okay.
like you are implementing your EVM from scratch, it's also the same problem that you can have different like security breaches inside your implementation. But as long as all these new VMs, I think they're interoperable. Just like if you are calling us like let's say move contract from Solidity, just like calling another Solidity contract, I think that's fine to have multiple VMs because it's essentially more flexibility for all the developers. But if you are requiring some kind of custom precompiles or like, I don't know, maybe some waiting times, I think it's bad. But as long as they are compatible and like easily interoperable, I think it's fine to have multiple options for multiple developers.
All right, this has been a very interesting conversation, but I want
ZKIP. We don't talk about shit that's coming. Like we really are very much builders, but if you protect certain parts of, I can't say too much on this. You can protect that chains can't double spend, and that's how you enable any VM to interoperate safely.
Right. Well, true. But
we'll talk about this afterwards.
People still do, lose money on the specific VM that they are on, right? So yeah, sure. They can like mitigate it or like put like a firewall between them, but that doesn't mean like it is actually secure. But sure.
I can't wait to learn more about ZKIP. But
you didn't hear it from me.
I guess, I want to switch gears a little and ask about, we've spoken a lot about validity proofs, whether they're like ZKPs or SGX. Are any of you guys working with fraud proofs? So like, typically, obviously, they're maligned for obvious reasons, but what are your thoughts?
That's for Bitcoin. So for Bitcoin, you have this script that is very, very limited. So you don't have even string concatenation or like multiplication. So it is still like the primitives of ZK proofs. If you want to build a snark, then you need to have pairings, you need to have multiplications. If you want to build a Stark, you need to have Merkle tree verification and multiplication, and these primitives doesn't exist on Bitcoin. So what we do is currently it works just like a sovereign ZK rollup where all the proofs are inscribed and statives are inscribed in Bitcoin. But at later point in the time, if you aggregate all these proofs and essentially have a single light client proof that also kind of light client proof of Bitcoin because it outputs a block hash. And that proof is essentially optimistically verified in Bitcoin. So if you want to build a snark verifier in Bitcoin today, it will take, I think, around 5 gigabytes or something of Bitcoin script, which you cannot run in a single Bitcoin transaction because a block is limited with 4 megabytes. So what you do is simply chunk this verifier into like multiple chunks and sign each input and output with Lamport signatures, which is essentially verifiable in Bitcoin script. And then you can optimistically verify a ZK verifier. That's where fraud proofs comes in. This is the architecture part of the BitVM, which is a recent innovation on Bitcoin. And what you do is you simply divide this 100 gigabyte, let's say, script into chunks and sign each input and output with a script hash, let's say. And then you run this script in Bitcoin if necessary, unless one of the verifiers challenge. It can be permissioned or it can be permissionless, so that you can verify this rollup or whatever you are building with ZK. But it is not possible to verify everything in single script. That's why you need fraud proofs to verify ZK proofs, especially on Bitcoin.
I'm not going to touch the Bitcoin L2 part. I also don't consider Optimium's L2s at all. But
yeah, I do also.
Yeah, but there's Bitcoin L2s have off-chain data, so
yeah, we are on-chain data.
I think fraud proofs get more shit than they deserve, honestly. Like, it is very solid technology. Like, they're one-of-n security assumptions, great. The problem that you have with this is the second you want interoperability. If you want fast interoperability without like centralized actors acting as middlemen, extracting high fees, which doesn't scale, by the way. First of all, technologically, it does not scale to have trust zones and super centralized actors like in the super chain, like not gonna scale. Second, any like traditional applications are really price sensitive, and to pay 0.5%, 1%, 2% for like enabling this through centralized actors doesn't scale, and it's not the right way to do it. So for this to build something like the Elastic Chain and you having interoperability between these, let's call them shards, you need ZK and you need the fast finality of ZK. So like fraud proofs are great tech. It's just not going to work for getting beyond the scalability of a couple of chains.
Yeah, hopefully in Bitcoin especially, if we get something like OPCAT, then we can implement Stark verification under 4 megabytes, hopefully. It's still a work in progress by Starkware team that is open source code base. I think with this kind of new opcode changes, we can get instant verification, and I also agree we should get rid of fraud proofs for the sake of interoperability and the delay.
Yeah, maybe another view I want to add is that like slightly change the view like from like maybe like 1 year ago where ZK is the only endgame. I still think like there will be a world where OP still exists, but it's different type of like block space like they want. Like someone just really want like cheap transaction. They want like EVM run just on one server. They don't need to pay for approval cost because regardless of like how much you can do on latency side, the theoretical overhead for circuit compared with the programming is just large. It's like 1,000 times larger. And the Visa, Google, all those kind of large companies, they build their infra. Even if they are centralized, it's still very costly infra. And then you are basically adding approval or something is times like another 100 or 1,000 to those existing infra. So that's why I think it will be a world where coexist. But for those kind of like chains which don't need ZK, they are very, very specific to, for example, it can be a regional chain. It can be very specific to certain applications. They only need one-way transfer. Like you can transfer from ZK clusters, like many different ZK chains, one way to this OP chain, but they don't need to withdraw fast, really, really fast, because yeah, I think it almost can be like sort of as a branch where you take money from your main account as and trading on this kind of trading account, but you don't necessarily need to kind of move back that frequently, and then like that type of thing. So because what I see as like very, very large scale, and it's still like might be problematic, and especially like because like so far like large ZK rollup companies, they have the ability to fix any bugs in time for if, for example, Polygon recently has for example there are some problem with the circuit or bridge, whatever, they can fix that in 1 day time. But imagine this happened to one of like many chains. They need to reach out to the team need to fix that. It's still harder to kind of fix ZK problem, but as far as you have some protocol engineer, it's relatively easier to fix in an OP setup. So that's why I think it will coexist, but the block space, the property will be very different, like very high security driven, want interoperability will go into this area, but others, they can accept this kind of one way like security and one way like this kind of like transfer, then like it will be fine.
But please don't use off-chain data on fraud-proof papers protocols. Those are side chains. Really bad idea.
Yeah.
Anything you want to add? Cool. I think we have some time for audience questions.
Yeah, I just wanted to ask, what do you think about like ZK-specific hardware? For example, what Ingo does, right? What do you think about the future of it and how it can be applicable for the ZK system?
Yeah, I think there are a lot of like really great effort on hardware company. We start off like doing a lot of hardware research. Actually, one of the innovation we build ZK EVM build Screw is that hardware can access like proving for like 10 times, 100 times, and I know there are already like first AC coming out. There are like many more AC coming out probably next year or something. But my biggest concern is still because the software keeps changing. There is like new proving system specific to cat check, making that like binary field and making that really fast. And if you want to make something very generic, then you might lose some kind of because if you make something very generic, it's very hard to kind of like make that very, very high efficient. And but if you make that more customized, then you are kind of accepting the trade-off for you kind of bind to certain proving system. So I think that's why I think for a certain like period of time, I think GPU will be enough to use. But I do hope to see like once, especially with prover decentralization, like more people opt into this kind of like having really fast enough prover, and then like over time, like people are not like changing their software stack because a new paper come out. It's because they can already get sufficient speed up from hardware. So it's like a chicken and egg problem. So imagine you have a better proving system, and now you have a better hardware, and you choose this hardware, and then because this hardware can give you very specific speed up, it's not necessary for you to switch. So I'm expecting to see like when this kind of hardware and software, like this kind of really nice coordination can happen, and then like I think more proving system might converge into that direction. But I think right now it's still changing very rapidly. There are some components like that can be accelerated, some elliptic curve operations, FFTs, but I think only accepting those kernels are not enough. Like you need end-to-end speed up, which require generic, which require hard design. So it's a very hard problem, but looking for more effort to make that happen.
If we think of the medium term, or long term. Like there will be a point, like no, this was the perfect answer, but there will be a point where it's fast enough, right? Efficient enough. Like there are not every application needs the highest possible throughput, like specialized hardware. So honestly, like proving systems will solidify over time, and like whether it's like RISC Zero or SP1 or ZKOS or some of these proof system Halo 2 and certain, okay, well, there will be a point where it starts making sense to standardize hardware for those, and they will be coming online also in the short term. But it's really like there's no question it'll happen. It's just a matter of time.
Hi. Quick question regarding a multi-prover. You are doing a multi-prover with Automata, ZKsync. You're also implementing some kind of TE multi-prover. What happens if you have, let's say, 4 or 5 different proving systems and they disagree with each other? Which one is right? Which one is wrong? Do you then have a multi-sig of multi-provers?
Yeah. Some governance like that. Like there will be some threshold, and even not agreement. Like you reach 3 prover, and then you can already like start proceed.
Okay, makes sense.
You can also
I don't like the word multi-sig for this one because it's quite different than, but
Yes.
cryptographic majority.
yeah,
I think we can agree on that.
you also don't need like governance to kind of like disable proof types if you have like multiple ones. So if like they kind of like disagree between them, then you can already disable them automatically, so they can't be used anymore. And then upgrade if there's actually a bug found and something like that. So the governance is just to kind of like, well, we enable something if something is buggy, but you don't need it to kind of like disable buggy proof types.
Okay, cheers.
I think earlier, I think there was some discussion over this, but just curious about like, some of these layer 2s, layer 3s, they commit proofs, but they're sort of like pre-confirmations of state transitions. I think there are a lot of security assumptions behind this, and potentially many things that could go wrong. Where do you project the world for like distribution of transactions over this scenario, and like, given that there are many security assumptions, and where do you think? Where's the middle ground for most of these things?
I mean, one thing that honestly helps with that is building like an ecosystem of chains, because then you can use, like, if you have a common source of truth and you're not having to bridge funds, you're just marking them somewhere else. That already gets you a massive way towards reducing security assumptions. Maybe I'm missing part of that, but that's honestly part of the reason we're building this. And like, you can have all these different applications on this sort of internet of value without making stupid trade-offs, bridging to other like sources of non-deterministic sources of truth.
Yeah, to be honest, I'm not a fan of like the world that has like, I don't know, thousands or 10,000s of rollups. Instead, I think we should have a one big rollup that can act as almost like a L1, but with L1's safety, other than being a sole L1. It can have its built-in proof of stake, it can have its built-in pre-confirmations, and if you don't have any like data through output limits, like something like volition model, that can also be a rollup and volume at the same time, then you can only need L3s if you need to customize that environment that much, so that you need to build a new chain. Other than that, I don't see any reason to like build thousands of multiple single and small rollups and then try to solve the same problem again and again.
I would just say, again, if there's a common stack, common source of truth, then it's just an application. Like you don't even have to write a rollup for it. Like RTech will take care of that for you. And then you just deploy your application. You can keep deploying instances the way you do on the web to get more throughput. And then you're not like, no one's having to reinvent anything. Like it's just the protocol works for you rather than against you.
No, I definitely agree. But instead of having some kind of aggregation layer that's called aggregation layer or like hyperchain or whatever, I think it can be also the blockchain itself. It can be the L2 that can act as an aggregator.
ETH-L1 will do this at some point. Like there will be changes. It's just further off. Like it's it'll be fascinating to see. It moves very slow, so it'll be fascinating to see in about 15, 20 years.
Bitcoin moves even slower.
Yeah.
Don't ask.
Feature, not a bug.
Cool. Well, thanks, guys.